In this video, we're going to do a quick introduction to graphs of functions. And as with a lot of my videos, I'm going to start by talking to you about sort of the big idea. So the big idea when it comes to the graph of a function is that every point on the graph of a function is an input-output pair. Okay, so what I mean by that is that if we take our axes and we say one of these is going to be the input axes, I'm going to make it the horizontal one in this case, and actually we're going to stick with that. You'll notice that that's the most common way to do it. We're going to make the horizontal axis our input axis, and our vertical axis our output axis. So this is kind of where that understanding comes from, that x's are always inputs. It's really kind of the graph, because generally what we call the x-axis is also where we plot the inputs on the graph. And so let's look at just a point. I'm not going to assign this to a specific function. We'll just say this is some point on the graph of our function. Well, if we look at its coordinates, so let's just say for the sake of argument, its x coordinate is a. Well, the y coordinate of that point is the output that this function assigns to the input a. So it's f of a. Okay? And every single other point on the graph is an input-output pair. So that leads us to think about, okay, so what do graphs of functions look like? And I'm going to take this opportunity to remind you one more time that a function assigns outputs to inputs so that no input corresponds to more than one output. And how does this translate onto the graph? Well, let's look at two examples. So here are our axes. So I'm labeling them x and y, but underneath the x, I'm going to say this is the inputs axis. And underneath the y, I'm going to remind us this is the outputs axis. And I'm just going to draw some doodle. Okay, I'm not really paying too much attention to the particulars. This is just some doodle, and we assume that it goes on forever, not really too worried about specifics. And I'm going to pick a few points on this doodle. I'm not picking them in any special way. If you'd like, you can look at more of them. But I do want to pick enough of them that you are sort of convinced that I'm picking like a pretty big sample of the points on this graph. And what we notice is that none of these points have the same x-coordinate. So you can see these, I'm going to sort of bring them down to the x/inputs axis. And you can see that all of these points have different x-coordinates. So every single one of these points is a different input corresponding to some output. Now, I'm not going to make the dotted lines because my picture will get very claustrophobic, but I want you to notice, just kind of as a, they don't all have different y coordinates. And this is interesting, but not terribly significant, because nothing in our definition of a function says that you can't have two different inputs that correspond to the same output. So for example, if you look at these 3 points, it seems like these 3 points have the same y coordinate. They have different x coordinates, but the same y coordinate. And that's okay. It's okay in a function to have different inputs that all map to the same output. In fact, you could have a constant function where all of the inputs map to the same output, as long as you never have one input that goes to more than one output. So this is an example of what the graph of a function could look like. So I'm actually going to say this could be the graph of a function. So now I want to think about, well, okay, then what would be a problem? What would be a situation where we have something that cannot go on for it to still be the graph of a function? Okay, so again, here are my axes. Once again, I'm going to think of my x-axis as my inputs axis, and my y-axis as my outputs axis. And I'm going to draw another doodle that I'm not paying too much attention to, except I want to make sure it has a feature like this. Rather than picking a bunch of points at random, I'm going to pick 3 very special points. I'm going to pick this one, and this one. So what do you notice about these 3 points? Feel free to pause the video and think about it and respond on your own. But what you'll notice here is that all 3 of these points, so these 3 points, have the same x-coordinate. And notice I'm going to leave a little bit of space after x-coordinate, but different y-coordinates. Okay, so if we wanted, we could say, let's say that this is A on the y-axis, let's say that this is B on the y-axis, and let's say that this is C. So that would mean if we call the x-coordinate something else, let's just call it x to give it a name, that would mean that the coordinates of these 3 points would be x comma C, x comma B, and x comma A. So we have 3 different outputs, A, B, and C, that all came from the same input. So we have 3 outputs coming from or corresponding to one input. And this cannot happen with functions. So this is not the graph of a function. The graph of a function cannot have this feature. So rather than calling it this feature, let's give it a name. So what I'm referring to is something called the vertical line rule. The vertical line rule says that since a vertical line consists of points that all have the same x-coordinate, in some sense that's the definition of a vertical line, the graph of a function cannot intersect any vertical line more than once. So if you go back to the example we were just looking at, you can see that the 3 points that we were looking at closely, they actually all lie on the same vertical line. So the reason I picked them is that they are the place for this graph where the vertical line rule fails. There are other places where it fails too, right? I just happened to pick one. So the reason this is important is it's not enough for there to be a vertical line that crosses the graph only once, like this one, or this one. That's not enough. What you need is for there to be no vertical line at all that crosses your graph in more than one place. If there's so much as one vertical line that crosses your graph in more than one place, poof, it's no longer the graph of a function. So that's the big idea behind the graph of a function. The points on the graph are input-output pairs, where inputs are typically x-coordinates and outputs are typically y-coordinates. It doesn't have to be that way, but for our purposes it generally is, so I'm going to stick with it for now. So what we're going to do in the next example is we're going to play a little bit with graphs of functions and information that we can get from the graph of a function. So stay tuned for the next lesson, and you'll notice that all of the lessons that we do from here on out are going to be related to graphing one way or another. So we've sort of transitioned into talking about functions from a graphing perspective. See you soon. Bye.